In this series of videos, we're going to be learning about the simplest form of hydrocarbon that actually contains more than just carbon and hydrogen, which is a group of organic chemicals that are what we call the haloalkanes. Now, from the prefix, you might be able to infer that the non-hydrogen, non-carbon elements in haloalkanes are in fact halogens, and your hypothesis would be correct. So, haloalkanes are alkanes that contain either fluorine, chlorine, bromine, iodine, or some combination of all of them. And the way that they form is basically the halogens are attached to a parent chain molecule in the same way that alkyl branches are, except instead of a carbon chain, it's a single halogen element, which is why halogen side chains are actually what we call alkyl halide branches, implying that they are not part of the parent chain, but are instead made of halogens rather than a hydrocarbon branch. Now, the good news about these particular compounds as far as structurally and nomenclaturally, if that's even a word, is that there are no additional rules as far as drawing the structures and naming of these compounds, meaning that we can use all of the original rules as far as alkyl branches go, except for the fact that we need to designate each halogen with a specific prefix. So the prefix represents bromine is the prefix bromo. Now the prefix that would represent chlorine is the prefix chloro. Fluorine is represented by fluoro, and iodine is represented by the rather awkward to pronounce iodo. Now, since all of the rules remain the same, this is why the order has been written out like this, because bromo would appear in a name before chloro, which would appear before fluoro, which would appear before iodo, because again, the rule of alphabetical order, which I can actually spell properly, alphabetical order, still applies not just now to alkyl branches, but also to alkyl halide side chains as well. So if we take a look at one sample molecule to write the name of and one sample molecule to write the structure of, we can see that these are not particularly overwhelming. So if we have to identify where carbon 1 is, we can see that this carbon here has two chloro side chains, so there would be a dichloro in this molecule here on carbon 1, whereas if we were to label carbon 1 on the other side, it would be here, meaning that these chloro side chains would be given a number that is too high. So we're going to start numbering from left to right like this and see whether that gives us the lowest total side chain number. So we can see that our parent chain is 1, 2, 3, 4, 5 carbons long at the longest point. So our parent chain, which I am circling here, we can call by the name of pentane, because again, 5 carbon long parent chain, single bonds only between carbons in the parent chain. Then if we identify the other side chains that we have here, we have 2 bromine alkyl halides, which means that we have a dibromo here. We have 2 methyls that we can see. It looks like we have a third methyl, but remember, the parent chain is the longest continuous chain of carbons, so this one here would be designated as part of the parent chain. So because we have 2 methyls, we would have a dimethyl. And then finally, actually not finally, because there's a halogen here, which we'll deal with in a second, we have a 2 carbon long side chain here, which would be an ethyl, and finally our last halogen substitution is an iodo. Now, before I write out the name, when you deal with this many side chains here, it helps to name what all of the pieces would be called before you put them in order. So here, both of our chlorines fall on carbon 1, so this would be 1,1-dichloro. Our bromines fall on carbons 2 and 3, so this would be 2,3-dibromo. Our 2 methyls fall on carbon 2 and carbon 4, so this would be 2,4-dimethyl, and our ethyl falls on carbon 3, so this would be 3-ethyl, and finally the iodo would be a 4-iodo. Then it comes time to put all of our side chains in order alphabetically. So B comes before C, which comes before E, which comes before I, which comes before M. So our dibromo, 2,3-dibromo, would come first, followed by our 1,1-dichloro, followed by our 3-ethyl, followed by 4-iodo, and finished by 2,4-dimethyl. Careful about the hyphen in there. Dimethyl, and then if we have some clever spacing trick here, then we need the name of our parent chain, which is, of course, pentane. So if we were to read the name of this monstrosity out, it would be 2,3-dibromo, 1,1-dichloro, 3-ethyl, 4-iodo, 2,4-dimethylpentane. Easy, no? Well, as most students find, drawing a structure from a given name is usually significantly more straightforward than finding a name when given a structure. And simply because the parent chain, once the parent chain is established, it's relatively easy to put the rest on. So here we see that we have 6 carbons and we have an alkane, meaning only carbon-to-carbon single bonds, but we see the prefix cyclo, which tells us that this parent chain is in the form of a 6-carbon ring, which we can draw as a hexagon like this, and then it's simply a checklist to put all of the remaining side chains on. So if we designate carbon 1 as here, just because I said so, we can put the chloro on here, and then here on carbons 2 and 5, so let's say that we read this counterclockwise, so carbon 2 would be here, and carbon 5 would be here. We have 2 3-carbon long side chains that are also rings, so this would be a cyclopropyl side chain, which we would write as a triangle like this, which is a side chain because the 6-carbon ring is larger. And then we have a second cyclopropyl on carbon 5 here. We have 2 ethyls, so 2-carbon long side chains on carbon 3 and carbon 4, which we can put here and here. And finally, on carbon 6, we have a second halogen substitution, which is an iodine like this. And we can see drawing a structure when given the name goes significantly more quickly than the other way around, because the parent chain is basically provided for us in the name. So as we can see from this example, adding in halogen substitution or alkyl halides really doesn't change a whole lot. It just gives you another 4 potential side chains in order to play around with when drawing or naming the structure. So to test your knowledge of alkyl halide nomenclature, see if you can take a look at the 2 compounds below, and if those prove to be not difficult at all, you can try the practice problems below to exercise your knowledge of haloalkanes.